Okay, guys, a very warm welcome to my lesson for today, where we are going to continue with what we started on physical sciences. I'm about to share my screen now, but before I do that, okay, this is where we were doing electric circuits. Okay, it's fine. Start from the top and then go down. Okay. Let me now share my screen. And then screen there. Okay. Okay, then it's fine. Let me quickly verify. Did you guys close in your schools? You closed today, isn't it?
Yes.
You guys closed, ne? Okay, then it's fine. In that case, we will just do a few questions, and then from there, we should be done. So that means during this period, you won't be given too much of class questions, then we should be done. Okay, so let's see. Obviously, we are then say electric circuits, and then I'll do that. Okay, then it's fine. So now let's say we have our battery there, and then we have that. Okay, let me do these. And then let me say I'm connecting, and then we'll say ammeter 1, ammeter 2. And then there I'll do that. Okay, let's say we have a resistor there, which has 1 ohm. And then here we have another resistor, which is 2 ohms. And then here, let's say it has 1,5 ohms. And then this one, let's say it has electricity there, let's say it's 20 volts. Okay, maybe let's again have ammeter 3 there. I'm therefore going to give you guys some questions to quickly work on. The first question that I would like for you to calculate is R effective. Calculate R effective. Only after you've calculated R effective, I will then guide you in terms of what we will do next. So let's see, guys. Did you see what I wanted you to do? So that means you need to refer to your previous notes to check how you calculate R effective or R total. Guys, did you see my question?
Yes, sir.
Katleho, Umpile, and Shianeo. Did you guys see my question?
Yes, sir.
Okay, then it's fine. I'll go back to the question. As soon as you are done with the calculation, what you then need to do It is to comment in the comment section and say, my R effective is equals to whatever that you get, and the answer is measured in ohms, OHM. So that means you just write whatever answer OHM as, meaning ohms. Then only after we'll move on to the next question. But now I want to train you guys on how to calculate the current passing through the parallel connections. I'm not sure what happened there, but it looks like the screen disappeared. Okay. Let me try to share again. Okay, I hope the screen is sharing. Let's see. Yes. Guys, remember, as soon as you get an answer, Hey guys, I just noticed I was disconnected, so the network is a bit poor on my side. I just hotspotted myself, but I did not see if you guys commented. Let's see. Atli Katle Umpilen channel. Are you guys still calculating, or have you got the answers? Guys, okay, RT equals something. Someone got an answer. Let's see. Anyone else who got an answer? I see Atli has got an answer. Guys, anyone else who got an answer? Katleho, are you winning there? Ompile, Chianeo, are you guys winning there?
Yes, sir. I'm still calculating.
Okay, then it's fine. At least let's wait for the others to quickly calculate and we'll see what they are getting. Okay. Mhm. Guys, are you still calculating? Are you guys still calculating? So remember, guys, always when you are given a question, don't redraw that and then you still rewrite the question straight away. Write number one, then you start calculating, because the moment you rewrite the question, all of that, then it becomes a lengthy process which will take much of your time. Okay, let's see. I'm not sure if you guys commented with your okay. We do have some comments there for okay. Okay. With you getting the same answer, I'm very much satisfied. Let me quickly check something. Yeah, no, I'm not sure if you've been catching up, honorable member, but I'm also expecting your calculations on that one. Please do work it out and find out what you get in the end. But generally, what we know is that R total equals R1 that you plus it with R2 that you plus it with R3. And then R1, you can use that one of 2 ohms that you must plus it. There you've got R in parallel that you must plus it with that one of 1 ohm. Then on a separate calculation, you need to deal with that one of R parallel, which is 1 over R1 that you plus it with 1 over R2. So what I said was, you will firstly write the formula. Second step, you substitute 1.5 that you plus it with 1 over 3. And then you just rewrite that exactly as it is, but this time around, you just say to the exponent of -1. And then you get an answer there. Let me quickly check on my calculator. So we have 1.5 and then 3. Then you will say, okay, I'm having 1 over 1.5 that you must plus it with 1 over 3, and then you close that, you say to the exponent of -1, and then equals, it gives you 1. So that means your R parallel is the same as 1. Just as I'm very much impressed, honorable members. Trust me on that one. You just say 1 ohm. So that means you go back to your original formula where you said R tot equals 2 ohms that you must plus it with the one for parallel, which is 1. You plus it with that other one, and then it ends up being 4 ohms. The reason why I'm very impressed is because you might not believe if I tell you that there's someone in grade 12 who still can't be able to calculate R tot, honorable members. So now, what I want you to calculate is the reading on maybe this one as number 2. Calculate reading on A3. A3 is that one, ammeter number 3. So very quickly, you guys can work it out. I will give you 4 minutes to work it out. You just need 3 steps. You write the formula, you substitute, you can do the calculation, then final answer. In 3 or 4 steps, you should be done on that one. But for those who are not able to calculate R tot, did you guys understand what I've done there? Does it make sense? Katleho, I think Katleho commented. And Drew, did you understand what I've done there?
No, sir.
So now, wait, Andrew, what did you say? You did not understand.
Yes, I can understand.
Okay, then it's fine. Just remind me, as soon as this lesson is done, just remind me to forward you the lessons that you need to catch up on. So just make sure, Andrew, that in case if you miss a lesson, you catch up so that when we have moved on, you know that you are not falling behind. Because one thing for sure, these honorable members who got it correct, they were attending those first lessons that you may have missed, but you just need to make sure that you catch up. After you've catched up on our next lesson, then I will answer your specific question. If you can say, I do not understand this part, then I will know which part exactly you do not understand, so that I avoid redoing that same thing, of which if you don't have the basics, you won't fully understand. Did you hear me on that one, Andrew?
Yes, sir. I heard you, sir.
Yes, 100%. Just make sure that as soon as this is done, I'll also forward you this lesson. You just need to catch up. Okay, then it's fine. And let's see. So now we are on the reading on A3. Someone got that answer there. Okay, then it's fine. The next question, we are now on calculating the reading on A3. A3, it is that ammeter 3 over there. Let me add more questions. Let's say V1. This is V2. That will be V3. I wanted us to have 30 minutes in today's lesson, but we'll go beyond 5 amperes idling on those calculations. Okay. This is how you calculate the current. You will say V, it's equals to IR. This is the formula to calculate the current, is that I. Obviously, the V is 20, which is equals to I on number 3 is what you are calculating for. Obviously, R thought we calculated it, it is 4 ohms. Then now you need to divide both sides by 4. Why both sides by 4? So that that 4 cancels with that. Then you have your I on 3, which is equals to 20 divided by 4. It gives you 5 amperes. So I hope it makes sense to everyone regarding how we calculate for I. So now the next question is, we calculate the reading on V1, V2, and V3. So that will be the next question. Let me just write it there and say, question number 3, we calculate reading on V1, V2, and V3. So very quickly calculate those readings. I will just give you a hint and say the formula is that one. When you have to calculate for V, there is the formula. When you have to calculate for the current, there is the formula. So I hope you guys were able to hear me on that one. So that means when you comment, you'll say V1 is equals to these volts, V2 is equals to these volts, V3 is equals to these volts. what you must know is that the electricity on V1, when you plus it with electricity on V2 and you plus it with the electricity on V3, it must take you back to the total electricity, which is 20V. So that means the 20V is the electricity for the whole of that house. V1 is the electricity that goes to TV, for example, and then V2 is the electricity that goes to the stove, for example, and then V3 is the electricity that goes to the light bulbs, where you have two light bulbs connected in parallel, one light bulb in the other room and the other one in the other room. So when you say V1, you plus it with V2, you plus it with V3, it must take you back to the total V of the house. Are you guys still calculating, or is it difficult? Guys, is it difficult, or are you still calculating there? Guys, what's happening there? Is it difficult, or are you calculating? What's happening there? No comment. Oh, let's see. Okay, someone has commented. Still bees. Okay. Let me give you guys enough time and not rush you. Let me not rush you and give you guys enough time to work on it. Okay, at least calculated 1055. Okay, it sounds convincing. It sounds convincing. Let's calculate it, please. It sounds convincing because when I add all your V's, they do add up to that. So, okay, let's see. So, we will say the reading on V1 should be equals to I times R. So, the question is, what is the current that is passing through V1, where V1 is connected? What you should remember is that the current that passes through there is the same, which is the one on A3. It only changes when it gets there because it splits. So that means when it gets there, the current is no longer the one that we calculated, which was 5. Because what we calculated there, it was 5 amperes, if I still remember. Yes. So that means everywhere in solid yellow, it's 5. So that means from there, the current there, it's 5, 5, 5, 5, 5. It continues as 5 everywhere in the second except when it gets to the parallel. So now it means it will be a 5 that we multiplied by 2, which will be 10 volts. So that's where I actually got the 10 volts for that one. 10 volts. When it comes to V2, you can see on V2, the current that is passing through there, it is the one for 5 amperes, that yellow one. It is the one for 5 amperes. It is the one for 5 amperes. So that means everywhere in solid yellow is 5. So the reason why we use 5 is because where V2 is connected, the current that is passing through there, it is the one for 5. That's why when we calculate, it will therefore be V2 equals to IR. Current passing through there, it is the one for 5. And then the R there is 1. So that is why we have 5 volts on that one. That is why there we have a 5 volts. And then when it comes to where V3 is connected, you see there where V3 is connected, you don't just choose the one for a 3, or you don't just choose the one for 1.5. Even if V3 was connected there, that V there, honorable members, you don't just use this. Even if the V was connected there, you always use this. You'll say V on parallel. You see V on parallel, it doesn't matter whether it's for the whole parallel or it's V for one of the resistors in the parallel. It will be I that you multiply it by the R. The R must be the R parallel. And then the current, you usually use the current that is on the series. So that means the V there, the current will be the one for 5 amperes. And then when it comes to the resistor, you use the resistor for the parallel, which is 1. That is why you get 5 volts. This is the formula for calculating V, which is on the parallel. It doesn't matter if that V is like that connected on that resistor. It doesn't matter if that V is like that is connected there. It doesn't matter if that V is connected like that. What you must know is that a V on parallel, it's equals to current for series times R for parallel. This is so that when you calculate the reading on A1, you see A1, that A1 there, you just check to say A1 is connected on that other side. So that means it is V, which is equals to the current on ammeter number 1 times R. Even the R will be the R where ammeter 1 is connected. V, it is that one that you calculated, which is 5, which should be equals to the current on ammeter 1. What is the R on ammeter number 1, or on that side of ammeter number 1? R is 1.5. So you will divide both sides by 1.5 so that that cancels, divide by 1.5. And what I know is that 1.5 is the same as 3 over 2. So on that side, you have 3 over 2, then it's 10 divided by 3. Okay, let me just do it like that and say 5 that you divide by 1 is 3,33. Yes. So that means you have your current passing through that side as 3,33 amperes. So that means now the current that is passing through that side is 3,33 amperes. It is obvious that the one that is passing through this other side, it will be 5 minus that one. Because we said this current that is 5, it splits. Part of it will go through that side and part of it will go through that side. At the end of the day, we know that when we combine them, it takes us back to that one of the unsplitted current. If you don't want to go that route of saying 5 minus 3,33 to know what will be reading on ammeter number 2, you can still do it the same way we have done it, where you say V is equals to I being current on ammeter number 2 times R. So V doesn't change, is 5. You have I on that. What is the resistance on that other side? It is 3. So you end up having a 5 divided by 3. What does it give you? 5 divided by 3, it will be 1 comma something, 1,67. Yes. So that means we have a 1,67 amperes as the current flowing through that other side. That should be it, honorable members. That should be it. I'm not sure if there's anyone who's got any questions before we call it a day for today. I wouldn't be surprised if Andrew will be having some questions. But let's see. Atli Katleho Umpile Chianeho. Any questions on your side? Andrew, just remind me to share the recording as soon as the lesson is done, just in case you did not understand.
Yes, sir.
But otherwise, other honorable members, are you okay there? Did you guys understand how to work it out?
Yes, sir. Yes, sir.
We are all okay, ne?
Yes, sir. Yes, sir.
Okay. Then it's fine. We will definitely leave it here, honorable members, and until we meet again. So we might not have that extra lesson or extra class tomorrow until you guys open. So that will be a chance for you to have some rest from or enjoy your school holidays. But just remember that during the week, the lessons continues as per the timetable. Okay, guys, we'll leave it here until we meet again.
Yes, sir.
Okay.